multiplication. We just need to differentiate. So we can get the relative error. We can get the relative error. We can now get the relative error. We can get the relative error. Relative error is given as okay. Kalama, how are you? Relative error. So the absolute error divided by the actual value. So can we work out that? There, we can. We can. So how do we work it out? So the absolute error divided by the actual value, that gives us the relative error. What is our absolute error? 0.39 divided by the actual value, 13.25. 0.0. That's what we are having as the, yes? It's supposed to be? Also, or it's a single one, 4-3. This one? Okay. So that gives us the absolute and the actual value to give us the relative error. Are we together? Now, the next thing, we can have an alternative. An alternative of getting the relative error. Or we can have an alternative and say that we go to the individual errors. Okay? Like the length, we say that the length is 5.3, okay? The error here is 0.05. Are we together? We can get the relative error for the length, which is given as 0.05 divided by the actual length, which is 5.3. What do you get? Let's see. 0.00923. 43. You're looking at the alternative. Then look at the width. Look at the width. We say that the width is 2.5, correct? Is it 2.5? Yes. So the error is 0.05. So we can get the relative error as 0.05 over 2.5. 0.02. Together? Those that are using their calculators, they seem to be lost. Eh? Are they there? Eh. Eliud, are you there? Eh, oh, you don't know. You don't know that you are Eliud. Now, what will be the relative error? So, for us to get the relative error, Therefore, we get the sum of the relative errors in length and width. In length and width. So we are going to add the relative error. Yes. It's not 2. Yes. What is it? 9, 4, 3, 3. It is recurring, but that's what we have. Sure. Have you used a calc? Good. So 0.009433 recurring. Okay, give it to 4 significant figures then. 0.009434. Okay. Are we now together? Now, we say that the relative error is given as the sum of the two errors in length and in width. So we're going to have it as 0.009434 added to 0.02. What is that value? 0.02943. 43 again. Now, look at the first value and what we are getting here. Are we able to compare? What do you notice? They are the same. Therefore, what do we conclude? What's our conclusion? When you cannot conclude? Yes? So all the methods are usable. That's correct? Okay, they are usable. So you can decide to have method 1 or method 2. Both methods are acceptable. Okay? Yeah, thank you so much. That's a nice lesson.